Hey, so this is part 2 of common ways how you can query the adjacency list model in Postgres. I will put a link in the description to the previous video or the playlist so you can catch up if you are just coming here directly. So I have this tree, and this table you can store multiple trees. The way you distinguish between each tree, so to know this node belongs to which tree is by the tree ID. And this is the root, these are the immediate children of it. And only this row has 3 children associated to it. It's pretty simple tree. And the way we query, like if I want to start from one node and then query the whole tree under it, this I hope this is clear, but it's a recursive query to me. It makes sense because if I want to start from the root, I can only get the immediate children of it because I know its ID. So I go search, give me all of the nodes where the parent ID is 1. I get these 2. Then I need also to go to the table, search again where the ID is, give me the nodes where the parent ID is 2 or 3. This tree could be really long, so you don't know where you stop or when do you stop. So you have to always keep adding these union all queries. I hope that's clear, but that's how I can view it as a recursive query. Of course, you can do multiple SQL queries and then concatenate the result in your backend application. But I'll prefer writing this as a single SQL query with recursive table common expressions, so recursive CTEs. I will copy the query here and then explain it, then keep enhancing it until we get something that we are happy with. So this is the simplest way, or one way, which is, I believe it's simple. Okay, so the recursive table common expression, recursive CTEs, starts with this 2 keywords. With recursive, it's similar to any CTEs, but you add a recursive keyword. You rename it, you specify how many columns or what columns there are. We have these 3. Now it contains 2 queries. The first one is the starting point. This will be run only once. So we select ID, title, and title as path from categories where parent ID is null, which means we will get the root, which is fruits. And of course, in a realistic example, you will put the tree ID also, so you can limit that. But I'm gonna keep it simple. So we start by the root. This will return 1 row. If this did not return anything, the whole thing will not give us any data, any rows returned. And we have this union all with the result from this query. This query says, select these things. I will explain them in a moment. From category path. The thing is with CTEs, you can reference them from inside of the CTE itself as CP. I'm gonna join it with the categories table where the cp.id, and if you think of it, I'm starting from the root, then getting the immediate children. Then from these immediate children, I will go get the immediate children of them, and this will continue running until this union all or until this query does not return anything. And that's the stopping condition we have for the recursive query. And this cp.id, these are the ID of the parents, and this is going to join them with the immediate children of them. That's what's gonna happen. And this concat here, I'm concatenating the path, which is the title of the node, the parent node, and adding this sign, then the title of the current node I'm in. So if I run this, okay, if I run this, I have fruits, I have apple, and the path to reach apple is from fruits to apple, then the green apple, fruits, apple, green apple. So that's actually really good. We can construct the full tree, and we know the path to reach each node, which is something really good. Maybe I should explain it again. So this is the starting point for the recursive query. Every row starts from here. We union it all from the result from this query. So the first iteration, I'm getting the root, and then I'm going to say, hey, give me the ID, title, and construct this path from category path, which only contains the root, and go join it with the categories table and search where this ID, which only starts with 1 row, which is 1, exists as a parent ID in the categories table. So this will return to me 2 and 3. So this row will be added, then these 2 will be added. Then because this is a recursive query, this thing will be run again on the result that we got from it the last time. So the previous iteration, we got the row 2 and row 3 as a result, which means we will go run the same query again and say where cp.id, which will be 2, equal as a parent ID here, we go get them. And also when parent ID is equal to 3, we go search for the rows based on this value. We get them, we store them in the CTE. Then we do the same thing for each row. That's what's gonna happen. Until this query returns nothing, then we stop. So running the full thing, I think I need to something with the white spaces is missing something up here. Yeah, okay. But like this, I get each node, its ID, and the path to reach it. That's pretty cool. That's might be even what you need in your application. But I'm gonna show you a different thing. First of all, you can represent arrays in Postgres, which is something really practical sometimes. And you can convert strings to arrays. I'll show you how. So string to array, you give it a string. And you give it, it's like the split function in JavaScript. You give it a delimiter, I think. That's the name. So empty string means the whole thing is just one element in an array. So we get an array that contains hi, but let's say and the delimiter will be exclamation mark. We get an array of 4 elements, hi, mo, and zz. So I think that will be a nicer way to represent the path as a list, and then you deal with it in your backend. The way I'm gonna do it is say request string to title as path like this, and to give it an empty string as a way to just keep the first element as a single array, and that's it. Then because this is an array, and this here we need to convert to array also, and concatenate it with the previous array from the previous array iteration. And the way to do this is there's a function called array cat, which stands for array concatenate, cp.path, and string to array the current title, and give it an empty string. Oops. Run this, and now you get the path as an array. And this is really easy to move to create a dictionary from on your backend, because the title of the nodes are unique. So this could be the key, and the value could be containing the ID, the full path, how you can access it. So that's pretty useful in my opinion. Now another thing you can do is finding the depth or level for each node. That's actually really easy to do. I'll put this on a new line. Zero as level, because the first node is 0 if you want to start counting from 0, and we know this is the starting point for each tree. This is badly formatted, I'm sorry, but in the link below, in the description below, you can find a link to the code to be much more formatted. And here will be cp.level plus 1 as level. And if I run this, oops, you can see this is 0 because it's the root, this is 1, and this is 1 because they are, I mean, you can see it even in the path. That's level 1, these are level 2. So yeah, it's pretty cool that you can do this. And just from this point, I think you can do all sorts of things, like going for selecting a specific node and then going down to reach the leaf. And this is by only changing this part. This means it's the root, but if I want to select a specific node, I can say where ID is equal to 2. This will start from this node and then go to its leaves, which is these 2, which is these 3, or basically gets the full tree under this node. So this is how you can go from any node to reach the top, to reach the bottom, which are the leaves. Or you can select, or you can start by a specific node. Let's say I'm gonna select this leaf, 6, which is red apple. And I need now to go from that leaf node until I reach the root node. If you think about it, it's just by switching this condition, because here I'm saying, hey, go to this node, which is I'm getting from the first query, go find its children by comparing the ID of it to the parent ID in the same table. But if I switch it, this means go the parent ID I currently have, which is 2, go find it in the ID column in the same table. So this means, hey, the parent ID here is 2, go search here for 2, I find it, that's it. And now go for this row, the parent ID is 1, go find it. So if I just switch this condition, if I run it now, I probably maybe because I need to select it actually, yeah, my bad. So select the parent ID. Now this will work. C.parent ID. And also specify it here. Okay. So yeah, you start from here, and that's how you reach it. I mean, that's how you reach it from its level. But if you want to go to apple, it's from red apple, which is the leaf. You go to apple, then you reach fruits. That's the path from the bottom up. Let's go to another one, which is more maybe. Let's go try 3. Yeah, so from the leaf to root. I hope this was useful, but that's pretty much it. These are the things that you will usually do. Yeah, that's it. That's it for this series, I guess. Bye.